5 Weather Classroom. Bill Taylor here in the KENS 5 Digital Center. Sitting 6 feet to my left, maybe 7.5, is meteorologist Megan Massey, my co-pilot for our debut. So glad you could all join us. Please comment, say hello, ask a question. Please be patient. Remember that we've got a scrolling live feed, so we might miss a couple of questions. Please feel free to re-ask. Today's topic is going to be the atmosphere, so we're going to get into what this is all about. And then each and every day in the coming days and weeks, we're going to be tackling all topics of meteorology, and I'd love your feedback. I'd love for you guys to help produce these segments. If there are future topics you'd like us to tackle, we will be here to do just that. We've got the greatest team of meteorologists KENS 5 has ever had, and I really mean that. So I'm real excited to get this staff and this team on board with our weather classroom. What a neat medium. Hi, Katika, how are you? There's Windcrest. Hi, Megan. Mari Bells and Shirts. Good to see you. Ursula's here and watching. Good to see you too. And Monica, thank you. Good afternoon to you as well. So I wanted to start out just kind of a fascination with what all of this meteorology and the study of weather is. You know, for me, it's always been that it's so much larger than us. I mean, is it even comprehensible that we're spinning on this big rock that's being hurled around the sun at about 67,000 miles per hour while it's tilted on its axis and spinning at about 1,000 miles per hour? So all of that is happening as we're here live on Facebook, as you're sitting at home right now. That's what's happening on this planet. And for me, that's always been so fascinating. Those are just the outer mechanics. And you think about just how much larger all of this is than us. It's pretty humbling. And it's also at the same time so interesting to learn more about everything that is moving and operating on our planet, in our atmosphere, and in our solar system. I mean, that is why I think there's an innate feature in all of us to learn more about all of it, because it is just so much larger than we are. Haven at Timberwood Park Elementary. Hi, Katie. And by the way, thanks for the patience. We were working out some technical glitches on this end for the debut. Hopefully we won't have those in days to come. So one way, we're going to talk atmosphere today. Again, questions, please bring them in. There's Luke from Hollywood Park. How you doing, Luke? Grandma and 6-year-old Arius is watching. I know a lot of grandparents have become homeschool teachers, so God bless y'all. It's so cool. Joseph and Mary Beth, Holotians, 3rd grade. There are Kuntz Coyotes in the house, not Kuntz Krugers. That's Kruger Elementary in Helotes, just outside Helotes as well. All right, so the atmosphere, as I've always heard it put, and this is a great way to think about it. If we're on the planet, the atmosphere is this river and ocean, I should say not river, but ocean of air that surrounds the atmosphere. You know, I talk about that spin, right, on our axis. I mean, keep in mind that the atmosphere is spinning too, so that everything you see inside of the atmosphere is spinning at 1,000 miles per hour. You know, you ask yourself, how could we be spinning at 1,000 miles an hour? I don't see us passing anything, because everything you see is spinning at 1,000 miles per hour. See, when you're inside of a vehicle on 1604, driving at 65 miles per hour, if you're doing a speed limit, right, or 70. Well, everything inside that car is moving at 70 miles per hour. If you look at your backpack or you look at a pencil while you're inside that car, it's also moving at 70 miles an hour, right? So it's the same principle in the sense that the atmosphere has everything inside, and we're all spinning at 1,000 miles per hour, which, by the way, that's the average of the planet Earth. It's always been said that's at the equator. We move up to the northern hemisphere, and scientists approximate about 850 to 900 miles per hour here in the United States. Alexandra, how are you? Good to see you. Andrew, crazy weather, right? Absolutely. The good news is we've got lots of sun in the forecast. Sterling from Texas. Hi, Kayla. Great that you're here. St. Helens Church School in Bernie. Hi, Dawn. Glad you guys are here. There's Daniel at Kruger. I mentioned Kruger, right? That's awesome, Daniel. Glad you're here. All right, so let's talk about layers of the atmosphere. How this works, I always equate it to a piece of lasagna. Who doesn't love lasagna, right? Lasagna. I like lasagna. Megan loves lasagna. And Megan's going to keep an eye on these all these comments too. I'm giving shout outs. We've got Los Reyes in the house. Good to see you guys out there at, what is it, Triana, right? That's where Los Reyes is, out in Helotes, past Helotes. All right, so look at that lasagna with layers, right? You've got the pasta layer, you've got a cheese layer. If you're like my wife, she makes it beautiful with the meat layer, and then we're back to a cheese layer, then back to another, right? Layer after layer. That's exactly how this atmosphere works, this ocean of air that surrounds us. And the first layer is what we study, the troposphere. Say it with me, troposphere. And you can see all the layers right here. Now here's the planet Earth, which, by the way, I'm going to give a shout out first to this person to my left, this incredible meteorologist, Megan Massey, who designed all these graphics. And this is a great way to look at this. She is a graphic wizard. So troposphere, stratosphere, mesosphere, thermosphere, exosphere. So we're going from bottom to top, not only in the text, but that's also how these layers are stacked up on each other, okay? So let's talk about the troposphere. The sun is going to heat all of these gases and create the weather that Megan and I and Andrew Wilson, Jeremy Baker, Stacia Wilson, Paul Morellis study every day. We report to you the sun's effects on heating these gases. Now, I love talking about the troposphere because there's always a misconception as to what it's made up of. But let's talk about what it is. It's where all our weather takes place, okay? I mean, when you consider clouds and rain and all of what occurs in our atmosphere, it's inside of the troposphere, okay? It's also the layer closest to our planet Earth. It is about 5 to 9 miles thick. So if you were to, look down a road 5 to 10 miles, well, just take that road view and turn it up. And we're going straight up, 5 to 9 miles in height from surface to top of the troposphere. Pretty incredible. But that's nothing. Wait till you see the other layers and how much thickness there is in those. And this is also the air we breathe. So that gets us into the misconception. What is it about the troposphere that we breathe in, right? So what makes up the troposphere? The number one gas is not oxygen. You'd think, right? We're breathing oxygen. You always hear, I need oxygen. We need an oxygen mask. Well, that's only 21% of the air you're breathing. 78% of the air you breathe is nitrogen. Nitrogen is the number one gas in our atmosphere, in our troposphere, I should say, in our troposphere. And 21% is oxygen. 1% is water vapor. Water vapor, that's water as a gas. It's an invisible gas as water vapor. We even use a water vapor satellite image on Ken's 5's weathercast to ensure you where systems are moving. It's like an X-ray of the atmosphere. So water vapor, again, water as a gas, and carbon dioxide, the one that everybody's worried about, that of course can lead to global warming and the climate change crisis. Well, carbon dioxide, and I can promise you that it is not even 1%, because argon is about 2%, and then carbon dioxide is on a list, and it's way down towards the bottom of that list of actual presence in our troposphere. It is like 0.0001. I mean, it really is out to the hundredths or tens of hundredths as far as the amount of carbon dioxide in our troposphere. So it's not so much how much is in there that alarms the climate change alarmists, if you will. It's the prediction of what's to come and how much could be in our atmosphere and the effects thereof. So that's part of all of that. Emma's here. Hi, Leslie. Good to see you. I'm glad you're here. And Josiah wants to ask, what layer are clouds considered a part of? That, Josiah, is the troposphere, for sure. Everything you see inside that 5 to 9 miles of troposphere, okay? All right, so that's the troposphere. Let's go up one layer, and you've heard about the stratosphere. That's the next layer just above the troposphere. That's where there aren't any storms or turbulence to mix the air. And remember, troposphere went from 5 to 9. Look at the change. Stratosphere goes 22 miles thick, more than double the thickness of the troposphere. The stratosphere is mighty thick, and it also includes one of the most important parts of our entire atmosphere, and that is the ozone layer. The ozone layer is key. It's what protects human beings from the ultraviolet rays of the sun. And there's a lot of concern about the depletion of the ozone layer. And remember that parts of ozone are created and established or replenished, if you will, when there's lightning strikes. That lightning strike of nitrogen, the natural occurrence, is what also helps create a little bit more ozone in our atmosphere. It's not directly replenishing those holes we're concerned with, but it is aiding in that process. But the ozone layer is is found within the stratosphere. See, I'm getting them all mixed up. The stratosphere. Ozone layer helps us all, of course, and it's very, very important. You're welcome, Bertha. Thanks for being here. Fair Oaks Ranch is here. Bo Diesel is in the house. All right, now, next up from the stratosphere in our layers of the atmosphere comes the mesosphere. Also about the same as the stratosphere, of about thickness 22 miles. This is where you'll see shooting stars. This is where space rocks, or what we call meteors, turn into meteorites, where they're coming into the atmosphere and burning up through that atmosphere. That's the mesosphere that burns up those space rocks. So that's when you see them, that's what you're looking at. You're looking at the mesosphere because it's kind of fading out as it comes in, okay? There are enough gases to cause friction and create heat within the mesosphere as well. And as I mentioned, 22 miles thick right above the stratosphere. Now, above the mesosphere, we get the thermosphere. And look at this, there goes the International Space Station. Again, Megan Massey, computer guru and whiz. I love that. That looks so good. Now, thermo comes from the word heat. That's the core word of that. Look at the thickness of this layer of our atmosphere. 319 miles. Man, did that change. So we went 5 to 9 tropos, right? Stratus 22, mesos 22, and now thermosphere 319 miles thick. See, this is when, again, you start getting into numbers that are difficult to wrap our minds around. Because, again, everything that we're talking about, that's what always fascinates me, is so much larger than we are. Now, the International Space Station, that's what's orbiting within this layer. The thermosphere is where that space station lives. And it's also home to a lot of low-orbit satellites. I mean, there are hundreds of satellites orbiting our Earth. Does anyone know the one natural satellite that we did not put up there? The one natural, non-man-made satellite that orbits the Earth as we speak? Starts with an M. It's the moon. A lot of you knew that answer. I know you did. Too many spheres. Debbie's like, she got sphere overload right now. Too many spheres. Hey, Tatiana, good to see you. Even middle school is here. I'm telling you, weather enthusiasts and students of all ages are welcome. And please, again, bring in your questions and comments. So,
I like how Leslie says how the ozone acts like sunscreen for the Earth.
Ooh, that's good.
Yeah, I like that.
The Earth's sunscreen, SPF, like 1,000 probably, right? The ozone layer. That's really good. That's a great way to equate it to what we do, right? And one of the most important proven things to protect your skin and your body is sunscreen. I mean, even when you're not going to the beach, if you've got fair skin, you should be putting on sunscreen almost every day if you're going to be outside at all. It's just always a good thing. All right, above the thermosphere, the final layer of our atmosphere, the exosphere. There's also what's called the ionosphere. And that's all. This is where we begin to, this is where the aurora borealis will take place. It's in these gases that the sun's ultraviolet rays interact, and you get those spectacular colors that are only visible in Alaska, sometimes visible in the northern United States. Just depends. In fact, did you know that weather people like myself and Megan Massey up in the Alaska area like Anchorage and Fairbanks, they actually give part of their forecast is the aurora borealis for that night, for that week, when some optimum viewing is going to take place. So the exosphere, the outermost atmospheric layer, if you will, look at this thickness now, 6,200 miles. What? 6,200 miles thick. It's still considered atmosphere of the planet Earth. Okay, and if you were tallying all these up, right, how thick is this entire atmosphere? That's mind-blowing. So, by the way, that 62,000 mile thickness, that equates to about the thickness of the planet Earth. So just imagine an atmosphere as thick as the planet itself, and you've got just the exosphere, okay? Then it's thermosphere, mesosphere, stratosphere, troposphere. So gases like helium, hydrogen. That's why they all talk funny up in the exosphere. That's one thing we're not going to spare you of, is great comedy in the weather classroom. Helium and hydrogen are found in the exosphere. And as I mentioned, including just above that, right? Is the ionosphere just above or part of the exosphere?
Part of the
It's part of the exosphere. And as I mentioned, that's where that interaction happens, and you get those really cool colors to occur in the aurora borealis. If you've never seen that, maybe that's going to be a topic for us here in the weather classroom at some point in the future. Thanks, Jessica. You do too. I appreciate it. Absolutely, Leslie. Anytime. Jonathan's at Brandeis High School. Go Broncos. Man, that was a heartbreaker. The basketball team making sports history, and it gets cut short. I hope they get to replay that game.
Jenny Howard on YouTube wants to know if we can post the graphics on Facebook for review, and we can do that.
Oh, we can do that. I'm really glad. Yeah, because not everyone might be available at this given time. We've got a good audience here, but we will definitely post these to Facebook. Is that probably best? Or even YouTube? And yeah, and then this video is going to live here. We're not going to take this down. It'll also live on our Ken's 5 YouTube channel. The only thing is, of course, we won't have live interaction, but the video will be there for future lessons, or if you want to go back and show someone else. Hi, Christy. Good to see you. Oh, thanks, Laura. Exactly. I mean, I'm an adult, and I love learning more about this every day. I'm forever a student of the atmosphere. I know about that much of this, incredible planet we live on. So it's always interesting. Plus distance, that's a really good point that Vera Carr's making. It's so very hard to find a matching planet because of all these layers, because of our distance. It is so precise as far as and our tilt. That's what a lot of it has to do with. If our tilt was just a fraction of a degree different, which I believe it's right around 23 or 24 degrees on its axis. In fact, can I give a shout out? My daughter Peyton, 8th grader, in today's lesson at the Google Classroom, she was building the planet on its axis, and she drew the axis using minus signs. She did a really good job of getting that 23. That's why when you look at a globe, it's never straight up and down, right? The globe that you have in your classroom or library that I know you miss right now, it's always tilted, isn't it? Because that's just a display that it's always tilted on its axis and being, again, hurled around the sun while spinning on that axis. Always incredible. What part of the atmosphere does lightning start in? Kimberly, that's going to be the troposphere. Okay, and as I mentioned, what happens inside that troposphere, that lightning is what makes your grass so much greener. There's a natural occurrence of nitrogen that comes down off those lightning bolts and sometimes even carried down in the precipitation of that same thunderstorm. The water droplets will sometimes be on that nitrate, on that nitrogen, and it'll spill out. That's why it's like a supercharged steroid for your lawns. It's not just the grass, not just the rain that makes that grass green. It's sometimes those big lightning storms that'll supercharge as well. How far do astronauts travel into the atmosphere? Ethan wants to know. He's 9. Hi, Ethan. Well, that's part of, like I said, the space station is in the thermosphere, right? Am I remembering correctly?
You may want to go back.
I might have to go back on that just to double check myself. Thank you, Megan. It's a good idea. Let's see. Yeah, thermosphere is where that space station lives. So it's orbiting the Earth, and astronauts are getting off and on that inside the thermosphere. Great question, Ethan. If the planets got out of place, would they hit each other? Clarity. Good. Let's bring some clarity to that. Sorry. All right. So I don't know, because you've got a lot of gravity at work there too, and everything is so precise. It's a pretty good question. Those orbital planes are pretty precise, and they don't alter too much at all. Now in the grand scheme of things and in the grand future of things, who knows, right? If that gravitational equation, that's really a question for old, who's our favorite physicist? Dr. Neil deGrasse. He's fantastic. I really like listening to him. 6th grader listening, wanting to be a meteorologist. All right, I love it. And Megan Massey gives a shout out on that. Now I know she'll say Mississippi State, because both of us have been students of Mississippi State Meteorology Program. Paul Morellis, even with a master's from Mississippi State in meteorology. Stacia went there too. If you want to stay in the state of Texas, it is gig 'em. Texas A&M has a phenomenal meteorology program. arguably the best in the state. I don't want to put it up against, I mean, Texas Tech has a good one as well.
UIW.
UIW here in San Antonio. If you don't want to leave San Antonio, thank you. That's a more recent degreed program for meteorology. Thanks to the great meteorologist and friend, Alex Garcia, instrumental in getting that program up and going. Love Alex, good friend. All right, wanted to visit the weather station. Love weather in space. Absolutely, Kayla, absolutely. I'm going to make a slideshow about space. Good job. That's awesome. And please feel free to use these phenomenal graphics built by Megan Massey herself. Space is cold. How warm is the thermosphere? Temperature of the thermosphere. That's a good question. Megan's going to find out for us. Notice how I just passed that one over? All right, we're double checking on the, average temperature, give or take a few degrees. There's meteorologist Andrew Wilson went to Mississippi State too. You got it, Andrew. Another Bulldogs in the house, man. Sorry about that. That's right. Now, in fact, another school, in case you're interested, that Stacia Wilson finished, and you might remember Jared Silverman. He was with us for about 11, 12 years here at KENS 5. Penn State University. Awesome program as well up in Pennsylvania, if you want to get up there.
The thermosphere temperature can range from 932 degrees Fahrenheit up to 3,632 degrees Fahrenheit. So it's a little warm.
Wow. Okay, so thermo means warm, right?
Thermo means heat, yes.
Give me that range again from the bottom,
So
932 degrees Fahrenheit to
3,632.
3,632. I mean, that's pretty precise, right? There's some great thermometers in the thermosphere, but that's, whoa, boom. See, once again, over 3,000 degrees, okay? Remember, a lightning bolt, an average of 60,000 degrees Fahrenheit. When we try to put it into our relative terms of things, it's so hard to wrap your mind around, right? Can we see behind the scenes of the Meteorology Center at KENS? Absolutely, it's Kerrigan and Corbin. So I hope we can soon get beyond this coronavirus quarantine and get back to normal. And when we do, we love giving tours. It's wonderful for you to come in here and get a hands-on look. So we try to set those up, and we'll have those as part of our schools. And, we'll definitely keep that in mind for the future. And then, yeah, we can give even a walking video tour on one of our upcoming weather classrooms. Mm-hmm. Yeah, Kimberly, you thought Texas was hot. I got nothing on the thermosphere. Yeah, it is going to be a hot week. So lower 90s. Nice, right? And blue skies. It's almost like today, this will be our average spring day. We just started spring last Thursday, the 19th, but we went into winter Saturday. Sunday, never got out of the clouds and drizzle. And today, temperatures are finally rebounding to more average, but by tomorrow, 80s. In fact, we might hit about 81 today, right? What are we thinking for today? Megan was the last one to really crunch the numbers for us last night. 81 or so. But by Wednesday, probably 91. I mean, it's going to be that warm. And I'm glad we're getting some sun and some heat, so you guys can get out of the house, enjoy some walks, and we don't have a rain chance until Friday night. We don't have a rain chance until Friday night. So that's great news for everybody. There's Grizz. What up, Grizz? Great job yesterday with the drive-in church. That was phenomenal, man. You guys, so awesome. Gateway Fellowship. Next Sunday, drive-in church again, 9, 10, 11, and 12, mygateway.tv.
We have
Great
a lot
stuff.
of good topics for our next classroom ideas.
So, yeah, what are you picking out and thinking? I love the tour idea. We give a tour on how we build our graphics, show you the weather center, how this all works at KENS.
You have the mic on here, so feel
Yep.
free to echo what I'm saying. But Andrea Gutierrez says, how do you know what the temperature is going to be, as in how we forecast?
Very good. Teach you guys how things cool adiabatically in the different layers inside that troposphere. There's warm air advection. There's a lot of science in that, and that's a great question that we'll tackle. So temperature, how we forecast, that could be a good topic.
Behind the scenes of our weather center.
I love that one. Give you guys a tour of how it's all put together.
Can the earth grow?
Will it be humid? It'll be a bit of a humid week, Angela. Or it's Eliana, 6-year-old question. I love it. Eliana wants to know about humidity. So yeah, it's definitely going to be a little more humid this week. We're a prevailing southeast wind here, so that means it's coming in. If here's San Antonio, here's the Gulf of Mexico, the prevailing wind comes from the Gulf of Mexico. So inside that wind is a lot of water, which translates into a lot of humidity for us, a lot more water in the air, okay? And that's what really we spend most of our year with. Not like Houston, they're so much closer to the coast. I mean, they get an onslaught of humidity. Or Southwest Louisiana, I know I got some Cajuns watching. I know I got Wyatt and Braylon at the very least, but that's where the humidity thrives. Southwest Louisiana, it's so humid, it'll start raining. I mean, you just need a snap of a finger. Brantley is 6. How do big storms start? Great topic, Brantley, and we're going to get into the dynamics of a thunderstorm later this week, the anatomy of a thunderstorm, and just exactly how those grow and build, because that can be serious business. Mother Nature will get your attention, right, with lightning and thunder, and when that happens, we've got to take warning, right? When thunder roars, go indoors. That's always the most important thing. My daughter in 3rd grade wants to know, where does the bloody moon come from? The blood moon. Yeah, so a lot of times that's going to be the layers of atmosphere you're looking through to see the moon. And the same thing happens with the sun. So it's interesting, as we're talking about the atmosphere today, and I'll get it back to the troposphere slide here, because that's obviously the most common and the most the one that we study, this one right here. And when you're looking through the troposphere, okay, and the sun's on the horizon, I'm just kind of, give me a moment here and I'll get you up. There we go. When you're looking through more atmosphere on the horizon at the sun, so that's going to be sunset, sunrise, you'll see a different color because of just how many gases, as I'm showing you here, you're looking through. And that's just the gases. Keep in mind that all the added gases and things that we add to the atmosphere ourselves as human beings and as industrial a nation as we are, and you can see that the different layers will change the color. That's why when the sun rises in our sky, it's directly overhead. You're not going to see that same color. Okay? It's going to change in color because of the amount of atmosphere you're looking through and the amount of particulates that are in your way. Why is it harder to breathe when I run outside in humidity? Have to run half a mile every day. Addison is 6 and wants to know about that.
Evaporative cooling.
Evaporative cooling.
It's hard to have your sweat evaporate when it's humid outside.
Excellent, excellent. So remember that when we're evaporating, it's a cooling process. So the air around that evaporation process will cool. And so when you have, and remember, your body is almost 3/4 water, just like the planet Earth is, okay? Same designer. And the key is that you're evaporating water off of your body. At the same time, there's a lot of water in the air. Well, you're not going to evaporate as efficiently. So a lot of that water sticks to you, and that's why the humidity feels that way. But as far as the running, when you're running, remember, the key, breathe in through your nose, not through your mouth. That's going to help you as far as what you feel on your lungs. When you're breathing in through your mouth, you're going to get a lot more of that air in, and it's going to start burning after a while. Eliana is 6. Why is the sky green during tornadoes and orange when it hails? Well, I'm not sure there's no rhyme or reason to those exact colors with those weather phenomenons. It would have to really be in the certain circumstance of time of day. A lot of times, like when there's thunderstorms in snow, you get a green sky just because you've got more snow that you're looking through. Those crystals, it'll start changing those colors. But there's a lot going on, and ultimately I don't really know the answer to that one. Future meteorologist Alyssa, I love that. My name is future meteorologist Alyssa. I'm 11, and I'd like to know, how many miles does a tornado travel?
It varies.
It varies. Like we had the one last week, traveled 40 to 50 miles.
The one in Tennessee traveled a lot longer.
Yeah. On average, how many miles do you think? Because I know on average it's a 10 to 12 minute weather phenomenon. I've always remembered that number. They can be moving at 40, 50 miles per hour when on the ground. This has nothing to do with the vortex speed. Remember, we're talking about speed of travel. As it's moving, I mean, it can cover several miles. There's no real, exact. It could be a third of a mile. It could be 50 to 60 miles.
You really have to have the perfect ingredients to support tornado longevity.
That's a good point. The perfect ingredients are in place to support how that tornado lives and how long. I mean, we had a funnel cloud just 2 weeks ago. over to TPC. It was just, vroom, it just occurred for merely seconds, and it was gone. Never did the full-fledged vortex down to the surface and become a tornado. That was just a funnel cloud. Bo Diesel wants to know why the Earth spins. Ooh, that's a tough one, Bo. I mean, why? I don't know, because that's how God wanted it. Yeah, it's another good topic. I mean, how it spins and what it, on its axis, we just know that it is. How are the elements different? The elements of the atmosphere inside the troposphere, I'm not sure. Thanks, Bertha, absolutely. Why do we get tired when it's cloudy? Liz is 12 years old. There's always been a correlation between your biorhythms and air pressure. We're going to get into air pressure because I love highs and lows and how they relate to your body, and we've got some wonderful graphics that we're ready to go on that in a future weather classroom. But let's just say that when pressure drops, which is going to lead to a more cloudy condition, your biorhythms are lower. You don't get as excited. And just the opposite is true with high pressure. So low pressure creates a lot more cloudiness. High pressure, just the opposite, a pressing air motion where the air is heavier and we have that pressing motion on the atmosphere from top to bottom. You can ask many teachers that are home now and many homeschool providers or many parents in general. The 4, 5, and 6-year-old population gets all amped up when high pressure's out. And high pressure is because just the opposite's happening. It rejuvenates. Your biorhythms are kicking. You get extra energy. It really does. I mean, there's a correlation. It's why the animal kingdom knows when the rain's coming, knows when the weather's changing. A lot of it has to do with pressure. It's why us old people, present company included, you'll start feeling aches and pains when pressure's changing. It's also leads to migraines. I know a lot of you who suffer from migraine headaches, and that has a lot to do with air pressure.
Right, joints, they can affect joints.
Joints, all of that. Great question. Love the questions. What do solar panels have to do with the sun? Well, that's what they receive for energy, right? How big can thunderstorms get? Joshua wants to know. 9 years old. Hi, Joshua. So thunderstorms almost can get as high as the troposphere itself, and even maybe tap into the stratosphere. I mean, they can get 6, 7, 8 miles in height. Okay, those tremendous, especially South Texas ones. We had them last week. When we get them up to about 50, 60,000 feet. And remember when we talk feet, there's about 5,000 to 6,000 of those in a mile, right? So for every, let's just round up to 6,000 feet, you got a mile, right? So you got 50 to 60,000 feet in height, one storm. That's why at the top it's gotten so cold and tapped into that colder air that you start getting down to. And remember, the higher you go and then it gets warm again with the thermosphere, you get cold, but then you get right back to the warm air too.
Kayla wants to learn more about space. I love space, so.
All right, Kayla.
More topics about
Yeah,
it.
see, we're writing all these down, and we're definitely going to be moving into these topics in weeks to come. We're prepared to do this weather classroom as we kind of wrap things up for this Monday in our debut, as long as you're at home with school. I really want to make that commitment to you right now, because this gives parents a nice break. It gives at-home teachers a nice, respite to take a walk and to grab a bite to eat, and let us take over. And if it's not working for 1 o'clock, we're going to do it at 1 o'clock every day. If that's not working for you, this video is available for you for future reference on our Facebook right here, or of course on YouTube as well. We're also going to mix it up. I know that Megan's going to be handling Severe Weather 101 tomorrow. What is severe weather? What we're more susceptible to here? Why a watch turns into a warning? How it all unfolds. And that, to me, is our most important job at KENS 5 Television. Keep you ahead of severe weather. When life-threatening weather is impacting our area, that's when we have to be on our guard, and we have to give you the most information. See, JJ9 wants to know more about stars, the black hole, right? Amazing, amazing stuff, and we're going to get into that for sure. What causes acid rain? So Hayden, that was a big scare. I remember back in the 70s, like late 70s, when I was a kid, acid rain was really scary. And it was because of the amount of gases we're putting into the air that water droplets are clinging to those particulates. Okay, like have you ever seen when it rains, like a good thunderstorm, and then there's dirt all over your car the next day? That's because the rain droplet it condensed over a piece of dirt or a piece of dust. So sometimes those darkening clouds you see, that is just holding a lot of West Texas dirt that's been brought up in the updraft, and then it's staying up there because of the consistent updraft of a thunderstorm, and it travels this far east, and when it comes down, that water droplet hits the surface, that dirt comes out. It doesn't happen every time, but that can happen pretty often, and that's kind of the same thing. Instead of dirt, sometimes it's popping onto some, bad acid, if you will. All right, anything else as we wrap things up? Look at all the, oh my God, I wish we could have gotten to everything.
There's a lot on YouTube.
A lot.
Too, but...
And a lot on YouTube too. God bless you all. Thanks for joining us. Again, please keep the feedback coming. btaylor@kens5.com is my email. And then all of our meteorologists go the same way. Megan is M. Massey. Andrew is A. Wilson. Paul P. Morelis @kens5.com. If you've got a question or a topic you'd like us to cover, we would be happy to do that. We're so glad you're joining us and so glad we can bring to you the KENS 5 Weather Classroom. That's going to wrap it up for day one. Thanks so much for joining us. Have a wonderful Monday, everybody. Take care.